So in this video, I'd like to talk about the current state of the C compiler for the Sol-1. I worked on the compiler for I think about 4 months now, since the last time that I stopped working on it, and I did a lot of changes and improvements on the compiler. Right now it's compiling most of the C language in terms of syntax. It does not have all the C library functions at the moment, and in C the library is the bulk of the language, as you may know. So C relies on this gigantic library of functions that each function does a particular task in C, so everything is not built into the language. So let's see, this is a small test program, so I think what I'll do is I'll try to go over a C program, and then go over the output and talk about how it's generated and what it compiles, what it doesn't compile. So here, for example, in this folder, C compiler / programs, I have a few programs that I wrote to test the compiler. So this is a program to convert a string into base 64, for example. There's a factorial program. There's a program to do some floating point calculations, which my compiler, that's the only thing it does not have at the moment, is the ability to deal with floats. That's the next thing I want to implement. I spent quite a lot of time implementing 32-bit integers, because the CPU is 16-bit. So the C compiler didn't have 32-bit capability, so I spent 1 or 2 months working on that, and it's amazing how complicated that was. So I have here Game of Life implementation in C. Let's see what else. There's a quick sort algorithm implementation. There's an RSA encryption in program here. There's the SHA-256. Never mind. I had this program and I deleted it by mistake while I was testing, so I have to recover that program. There's WireWorld. This is a automaton implementation that does some logic calculations things. There's the 1's. I'm not sure if you're familiar with this game, but it's an old game where you are in a cave and there are rooms, and you can either shoot or move into the rooms, and the 1 is a monster that is in there and can get you. So let's see, if we take a look at, let's say, the live program. So as you can see, we can include libraries. This is the standard IO library, which I'll talk about in a bit. We can define constants in C. We can create any types of variables, with the exception of floats, like I said before. So this is a variable array of chars, and you can initialize the array. Here's a big array for the current state of the game. You can declare functions, void, int, char, functions, etc., or you can use other data types like structs and enums. So you can declare local variables, you can use for loops, you can use printf, and you can use variable arguments in printf, if statements. This is the main function. So you have a nested for loop, have other for loops, and so on. That's the live one. As you can see, we can use pointers. So pointers can be of any data type and any indirection level. RSA, let's see what we have here. So as you can see, printf, you can use variable arguments in there. Get s, input a string. While loops, you have all the C operators like shift, mod, multiply, divide, etc. Let's take a look at this one. As you can see, we can declare enumerations like that. Global variables, of course. See, you can see you can have any level of nesting. You can nest any structures within any other structures. We have switch statements, so that works fine. So you have the cases inside of it, and you see it doesn't require curly braces in there, and then you have a break. If you don't have a break, then the statements will fall through. And then finally you can have a default as well. Here we're just using a multi-dimensional array in there. So that's that program. Let's see what we have in this one that I can talk about. You can have comments. There are a few libraries that I started writing. So we have stdio, stdlib, ctype. It doesn't have all of them. Here, yeah, just a bunch of text. One thing that I implemented that C does have is, for example, if you consider this piece of all these print statements, what you can do is delete this one and just have the string. So you can have one string here, and then right next to it or right below you can just have another string, and C will consider that a single string. It will concatenate everything for you. Let's see what else we have. Yeah, so the if statements are normal. Well, they're implemented, I mean. Return statements. While you can have continue inside loops or break. Let's see here. Yeah, so that's that one. Factorial is a simple one. Base 64. So this one. So types of variables. You can declare unsigned, signed. You can also have long and short integers. So short integers are the same as integers, which are 16 bits. Long integers are 32 bits. Let's see what else we have. So that's it for this one. So for example, you can declare structs. So if I declare struct here, you can have anything inside. So char C, let's say int I. You could have another struct inside. You can have nested structs, and you can also declare a struct. How they call it? Forgot the word, but it's a struct without name. So you just declare the struct like this, and then you give it a name to this field. Let's say, so for example, my struct. So you can declare structs like that inside of that, and of course inside this struct you can also declare another one. So it has, you can nest as many as you like. Let's say if you have a struct, and then you say, let's say struct my struct, and then you say char C int I, etc. semicolon at the end. You can have that struct declared in here. So you would do struct my struct, and then whatever name you want. So you can do that as well. You cannot declare type defs directly on the struct yet, but you could do, for example, type def struct my struct some name, and that will work as well. With that in mind, you can use structs as return values for functions. So you could have struct my struct some function and so on, and you can return a struct in there. You can have struct type local variables or global variables and so on, or enumerations. You can also have unions, some union whatever, like that. And as you know, in C, this will find the largest data type inside, and that will be the size of the union itself. So let's delete this stuff. Another thing you can have is inline assembly. So you have this inline keyword as ASM keyword, and you can declare assembly directly in there. You can have labels as well in there, or you can declare data. So if you say like .tb1, that will create a char bytes, or .dword2, that will create a word. You can also include files like that. So let's say let's create a simple program. Int I for I equals 0, I is less than 10, I plus plus. Let's say printf value, new line, I. So that's just a counting program. If I go here on the terminal and I do build test.c, so that will compile and will give you some outputs, and then it will generate the assembly. And then if we look here, this is the output. So we add some libraries, assembly libraries. No, this is just an export. It creates the main function here, and so the first thing it does is just generate some space on the stack for arguments. So you can have, for example, argv, so char argv char or int argc. This is for inline arguments from the shell, for example, but I'll delete it for now because with all the changes to the compiler, I'm not sure the state of this particular function. But anyway, so we declared a local integer variable which is 16 bits, so the stack will subtract 2 from SP here, and I have it so it will comment each C line on the assembly. So here's the initialization of the for loop. It will load the address of the I variable into the D register with the load effective address instruction. It will save the D register because the expression after the equal sign could change the D register, so we save that. It doesn't always do that, which is the case in here. So this assembler needs some optimizations to remove such instructions when it's not needed, but for now it doesn't. After that, we move a 32-bit value into the CEB combined register. It's not a 32-bit integer, but it does that because if it were, then it would be easier. But again, it's part of the optimizations. And then it moves the value into the address referenced by the D register, which is address of the I variable. Then it goes into the for loop condition, loads again, loads the address of I into D, moves the value into B, moves 0 into C because it's a 16-bit number, so we don't want to deal with the high part. Then it starts the relational expression. We'll compare that to 10. It does that, compares the result and jumps to the exit of the for loop if it's true. Otherwise, it goes to into the for loop block. The for loop block, we do the printf function, which in this case will load I again into, we'll load the address into D, we'll move into B. Here just does some swap because I need to correct something in my CPU, because whenever it pushes something to the stack, it reverses the order. I need to fix that into the microcode. But in any case, it pushes the value of B into the stack as an argument. Then it loads a string into B, the address of the string, which is the other argument to the printf, pushes that and calls printf. After it's done, it recovers the stack. After that, it goes into the for loop update, which will update the I variable, and here it will jump to the condition again. We'll test the condition again, and after that, after it's done, it will come out of the for loop. This is a syscall to terminate the current process. Now all the rest here are the libraries, so it will only it will only insert assembly for functions that are used. So printf is used, so it will add the assembly for printf. Now printf references other instructions, other functions, so it will recursively add whatever functions that printf needs. For example, if you go further down, there's this print signed long, for example, which will printf uses, so it will add that, and so it generates all the assembly like that for the entire program. At the end, it will declare data, whatever data is global variables or strings. So we have this string here, it was using the printf. We have some strings that the printf function uses. Then we have the heap declaration there. So that's more or less how it generates. That's more or less what the code generator looks like. Now let's see. I could show you the stdio library. So stdio is here. It uses some other libraries. It has some defines, has this file struct, has some fopen and fclose. I need to implement these. Still not possible to access files because my file system in the computer is it's a baby file system. I need to write a proper file system, and then I can write the open and fclose, but I just didn't do it yet. Anyhow, we have the printf function declaration here. So this is my own implementation of printf, which is a simple implementation. It can print 32-bit or 16-bit integers, unsigned integers, hex, char, or string. Have an implementation of scanf, have s printf, prints 32x. This function is implemented in assembly, as you can see. Print hex 16, etc. So it has all the basic IO functionality in there. Put char, scanf, and so on. We have stdlib, token for dealing with tokenizations, and yeah, that's it. This is an implementation of the old Star Trek program. So I use this to test the compiler, so it's compiling everything alright. The only problem is it generates code that is larger than the largest file size that I can have on Sol-1, so I can't execute that yet. Maybe I'll do a quick show quickly the structure of the C compiler. Yeah, so we have some declarations. Now I think I'll leave that to shoot another video because this is quite long, so it's almost 7,000 lines of code. So yeah, that's it. That's what the C compiler is looking like at the moment. What I want to do now is I'm working on adding a floppy drive interface into Sol-1 so we can use floppy drives. So yeah, I'll post updates when I'm done with that. But yeah, if you have any questions or comments, please leave them down in the comment section, and thank you very much for watching.